All right, so today's topic is scatter plots and lines of best fit, aka regression lines. Now, I know for a fact that you have done this before. You did this in Algebra 1, it was one of your competencies. So you've definitely seen this before. This should be no big deal. Okay, so basically, the situation here is we have some data. This is comparing the hours of sleep versus a test score for a history class. Okay, so we have this data. It's paired data, which makes it different than the data that we've been looking at thus far. So far, we've looking at only a single variable data. There hasn't been two different things. So now we're starting to look at data that's paired, which means that I have two different variables that I want to see what's the connection between the two of them. Okay, so the first thing I'm going to do here is I'm going to create a scatter plot. You know how to make these. You just find the points. Okay, so I want to find where 8 hours slept meets a test score of 83. So here's 8 hours of sleep. Here's a test score of 83. You know how to make these. All right, now just a couple of quick features. Notice that down here, there's this little section with that little weird jump. So you notice how it jumps from 0 to 60. That's a distance of 60, but then it's going by fives. You always include something like that just to show it's called a break in the graph. Okay, just to show that you're kind of making a jump. And it's almost like if you can sort of visualize taking the y-axis and like pushing it down, and that's what would happen at the bottom. That's what's going on there, okay? So you've got your basic table of, I'm sorry, not your table of values, your scatter plot set up. Down here, we have the hours slept, and this is the test score, okay? This is the independent thing. This is the dependent thing. We're trying to see what effect does this have on this, okay? So the thing that does the changing always shows up at the bottom. That's why we want this down here. Okay, so then I'm just going to go ahead and plot the rest of these. So after 7 hours of sleep, somebody got an 86. After 7 hours of sleep, somebody else got a 74. So that's going to go about there. After 8 hours of sleep, somebody got an 88. Okay, I'm just sort of putting these approximately where they go. It shouldn't be anything too groundbreaking for you. 790 would be here. 460 would be here. 989 would be here. And then 781. All right, so that is my scatter plot for these points. So question 1, create a scatter plot. Done. Question 2 also says make a scatter plot. So I guess that's also done. That was a complete oversight and kind of silly of me. So there we go. We've done 1 and 2 in one big shot. All right, so now we're going to talk about this thing called a line of best fit. Now, the idea of a line of best fit is it's just we're trying to create a line that best matches this data. Okay, it's not something that we are going to go like major detail in. There is an official way to calculate this, and there's like formulas and stuff that you use to calculate these. There is a official line of best fit, but that is not the major piece that we're going to look at. Okay, we're just going to look at kind of estimating them. So basically what you want to do is you're sort of looking at, okay, I'm looking for a line that when I put it in here, it's going to best follow this data. This data clearly doesn't make an exact line, but we want to kind of estimate it. And if you sort of look, you can sort of eyeball this and your gut should tell you like, oh, this isn't a good line of best fit because it's all the data's on this side of it, right? And this isn't a good line of best fit because all the data's on this side of it. And like, this isn't a good line of best fit because these points are really far away. So you want to kind of find a line that follows the data and sort of goes through the middle. Okay, it's okay if it's not perfect. All right, we're not shooting for perfection here. I'm thinking this looks about good. So I'm trying to make it so it sort of lines up with these guys and those guys and goes through kind of the bulk of the data. All right, so here's my line of best fit. I'm just using a piece of paper to make my line kind of straight. Okay, now it's okay if your line of best fit isn't exactly the same as this one. It's just we're eyeballing here, okay? We're not doing it out the official mathematical calculation way. We're just eyeballing, okay? So here's my line of best fit, and you're noticing that the distance between these points, we want to make the distance from each point to the line as small as possible. Okay, so there's my sketch of what my line of best fit looks like. Now, what is this line? It's basically a prediction line. Okay, it's a line that we're using to describe this that we can then use to make predictions about what's going to happen either in the future or for something that's outside of our span of data. So if I wanted to know, like somebody who sleeps for 5 hours, what kind of score are they going to get? Or if somebody who sleeps for 10 hours or 11 hours, what kind of score are they going to get? That's what this line lets us estimate. All right, but before we do that, we're going to calculate the equation of this line of best fit. You know how to do this. We've done this a million times before. This is just making the equation of a line. Okay, so what I want to look for is I want to kind of choose 2 points that my line goes through. So like this guy right here, it looks like it goes pretty well through the point 780. So that's going to be my first point that I'm going to use. And then I just want to find another one that looks like a good point. This guy down here doesn't look too bad, right? 460. Okay, so it's any 2 points that your line goes through. Okay, and when you're drawing your line, you can always be strategic about where you draw your line to make sure you have some good points. Make sure it goes through one of your data points or a nice grid point. All right, and when we calculate our line, we did this before this year, right? Calculating a line, the first thing I'm going to do is calculate the slope. All right, so we're going to find the slope. And the way that you find slope, y2 minus y1 over x2 minus x1. So 60 minus 80 over 4 minus 7. That's going to be negative 20 over negative 3, which works out to 20 over 3, right? And then I'm just going to grab my calculator. Well, I guess for now I'll leave this as a fraction. We might convert it later. All right, and then from there, you have to find your y-intercept. So we are going to find the y-intercept using y equals mx plus b. I'm going to plug in my slope, the 20 over 3. And then I'm going to plug in one of my 2 points. It doesn't matter which one. I'm going to use the first one. Right, plugging that in for x and y. I'm going to use that to calculate what b is. So 20 over 3 times 7, I'm just throwing that into my calculator, and that works out to about 46.7. And then from there, subtract that from both sides, and that's going to be about 33.3. So we've got our slope, we got our y-intercept. So the equation for my line is going to be y equals 20 over 3, or you could write that as a decimal form, x plus that 33.3. Okay, so that's the equation of my regression line or line of best fit. It's a prediction line. Okay, so then for question 4, they're asking me to use my line to predict for somebody who slept for 3 hours. So I'm looking at this and I'm saying, okay, this guy who slept for 3 hours, where would he fall on the line? Now your first thought might be, oh, if this is 0, that means that they fell below 0. But then your brain would catch up and say, oh no, in terms of finding where this line is, this would be more like 55. So I'm thinking this would be at maybe, 51, 52. So my guess using this graph is that it's going to be about 51 or 52. And then I want to justify my graph using my equation. So I pulled that one off using my line. Now using my equation, what I'm going to do is I'm just going to say, okay, well, what happens when I plug in 3 for x, right? 3 for my number of hours of sleep. Well, that's going to work out to just 20. And when I calculate that, it works out to 53.5, which is not far off from the guess that I got just by looking at my graph. Okay, so that's the general idea of how you make a scatter plot, how you draw a line of best fit, how you get the equation for it. This should be nothing new and groundbreaking, right? You are going to learn a little bit more about correlation next, which is the next kind of big topic that you need to worry about with scatter plots.